Today we're going to do chapter 6. These are the answers for today's questions. Questions 1. An inductor of 3 Henry is connected in series with a resistor of 450 ohm and an alternating voltage supply of 240 volt and frequency of 60 Hz. Calculate A. The RMS current in the circuit. B. The phase difference between the applied voltage and the current of the circuit. Questions A. Determine the RMS current circuit. To determine the RMS current, first you need to identify the type of the circuit that you are looking at. So in these questions, you are given a RL circuit. It is a combination circuit. So let's apply Vs equals to Iz. Now, why Vs equals to Iz? Why not VL equals to IXL? Why not VR equals to IR? That is because you are given Vs. So to make it easier, let's apply Vs equals to Iz. Because Vs and Z, they are coming from the same, which is the resultant family. But since you don't have Z, now let us calculate Z by using Z equals to square root R squared plus XL squared. Expand the equations. Z equals to square root R squared plus 2 pi FL squared. Substitute the values into the equations and you will get Z equals to 1217.2 ohm. Now that you have Z, let's solve the questions. So Vs equals to Iz, substitute the values into the equations and you will get I equals to 0.197. Questions B. Calculate the phase difference between the applied voltage and the current. Now let's have a look at the phasor diagram. So this is a phasor diagram for RL circuit, where VR is lying on the X component and VL is lying on the Y component. And the resultant is Vs, which is our applied voltage. And if you look at I is lying on the X component. It is in phase with VR. The angles between Vs and I, we call it phase angle. So the phase angle right here, okay, this is the locations of the phase angle. But there's one question. Now we don't have VL and we don't have R. What can we do? Well, the phasor diagram can also be drawn like this, where R is lying on the X component and then XL is lying on the Y component, where Z is located at an angle that is same as your Vs. So now that you have the phasor diagram, let's apply the equations. Tangent theta equals to XL over R. Rearrange the equations and substitute the values in the equations. You will then obtain theta equals to 68.3 degrees. Questions 2. A tuning circuit in a radio consists of an inductor of resistance 0.5 kilo ohm and inductance 1.5 microhenry, and a variable capacitor. What is the capacitance of the capacitor? When the resonant frequency of the radio circuit matches the frequency of an FM radio station of frequency 97.4 Hz. B. What is the impedance of the circuit at this frequency? So if you look at these questions, the 97.4 Hz is actually your resonance frequency. Questions A. Calculate the capacitance of the variable capacitor. Now, since you know this is a question related to resonance frequency, so let's look at characteristic of the circuit when it is at resonance frequency. So Xc equals to XL. Expand the equations. You have 1 over 2 pi Fc equals to 2 pi Fl. So if you look at the circuit, you have all of the information. So substitute the values into the equations and you will get capacitance C equals to 1.78 farad. Questions B. Calculate the impedance of the circuit. Again, let's recall the characteristics at resonant frequency. So at resonant frequency, impedance Z is equals to R. So given R is equals to 0.5 kilo ohm, therefore Z is also equals to 0.5 kilo ohm. So that's all for today. I will see you again tomorrow.